I kind of like, if I can, to start off this sort of thing with a pithy quote that's spelled with a TH. I've got two of them. So following the presentation on eclipses, I think it's appropriate from the sublime to the ridiculous. That's number one. But I remember one, I've used it in letters to the editor out of Macbeth. And it's a tale told by an idiot, full of sound and fury, signifying nothing. And I like that a lot. Anyway, hope it doesn't apply. I'll let you folks decide. So January 12th to February 9th. All of this assumes that clouds don't exist. So yeah, take it with a grain of salt because they do, as we know. But this month we do get to see some effects of astronomy. Spring tides, not king tides, okay? Spring tides is the proper term. And that lovely word, syzygy. It's an example. I didn't know what it meant till 20 years ago. And I've been trying to figure out a way to play it in Scrabble ever since. There's only two Y's in a bag of Scrabble tiles. So you've got to go syzygious or something, or use a blank. There is a brief appearance of Mercury. This is not the right time of year, unless you're in the southern hemisphere, at which point, yeah, Mercury's right there, right beside Venus, and you can see it. Jupiter's moons, I find fascinating, and there's some neat ones. And if you want to get up before sunrise at the end of the month, and you've got something to help you see through morning twilight, 2 degrees above the southeast horizon, you may be able to catch, this is really hard, Mercury and Mars. Mercury's bright, Mars is not, because it's on the other side of the solar system. So here we are. There's a little screenshot from heavens above that shows the moon, the sun, and Saturn as of yesterday. So the moon is just past new. It's also at perigee tomorrow. So it's as close to Earth as it gets. The sun is closest to the Earth on January the 4th. Our orbit is less elliptical around the sun than the moon is around us. So the variation isn't as much. But the cool thing about tides, they vary as the inverse of the cube of the distance between the bodies. So you've got tides between the Earth and the moon, and Earth and the sun. The moon accounts for about 60, almost 70% of the total tidal effect on Earth, 65, I think. But because it varies with the cube of the distance, a 10% change up or down in the distance, particularly with the moon, because you can get that, will change the tidal forces by up to a third. And that's why we have spring tides. When moon, Earth, sun, all in a line, or sun, moon, Earth. So new moon or full moon. Other things influence it. There's about 9 of them, and I don't pretend to know them all, and I won't try to explain any of them. But we get a really big tidal range this weekend and a month from now. February 9th to 12th. And even with the clouds, you'll be able to see the effect because gravity works through clouds too. And that's the origin of syzygy from ancient Greek. I used to be able to pronounce that because you have to learn the Greek letters in engineering. And I used to know what some of them were. And it's the shortest word in English that contains 3 Y's. So syzygious is the adjective. Tides. And can you see the cursor moving? Oh, yeah. Okay. So Thursday the 11th, it is now Friday. And the tide is going out fast. So the high was 4.8, 4.4, 0.3. And you notice it's going down quickly. This super low tide is a little bit 3 inches higher than this one yesterday. But the high tide, 4.9, that's almost as high as it gets around here. So if you're kayaking, you're not going under the Davis Bay Pier. You're going around it. And it's just as high on Sunday. So you can toddle on down. I have seen low tides. In fact, you may have seen the pictures in the paper I submitted with one of my articles on low tides, certainly in the online version. And there's a group of pilings on the north side of the Davis Bay Pier. They're not all the way out where the pier is now. They were put in for some other purpose. They're about 15 feet this side, shore side of those ones out there. And I think it was 2 Christmases ago, they were actually dry. You could walk to them without getting your shoes wet. And yet, 8 hours later, you couldn't kayak under the pier. So you can get, there's a lot of water moves in and out. So that's the tides. The other effect, of course, Seashell Rapids. I think it's 200 million gallons go in and out twice a day, 2 cycles every day. When you get the highest tides, you've got the highest difference in height driving the water in and out of the inlet. So January 13th, 6:35. This is the flood. This is the ebb. And has everyone been there, I assume, or most people have? Okay. The geometry of the seafloor means it behaves differently on a flood compared to an ebb. On the flood, it's going into the inlet. Well, it's shallow in there for a half a mile. And the water has to move fast enough that it builds standing waves. Those are the equivalent of a shock wave in compressible fluids. But in water, you get this standing wave curling over. It's called a hydraulic jump. When it comes out, it basically drops off a cliff that's at an angle to the flow. So it's dropping off and swirling. And you get these whirlpools as bigger than this room, twice the size of this room, on a real big ebb tide. And I mean, you could put a 30-foot boat in there and it's gone. I've watched logs disappear. They surface probably 1/4 of a mile, half mile down eventually. So going swimming is not recommended. Now, I'm hoping to take some unsuspecting relatives of mine up there on Sunday to see it. Now, as you notice here, this is gray, that's dark. So there's no point in going up there at night. One, you can't walk there successfully. And if you get there, there's nothing to see. So this is what we'll be able to see on the 13th. 14th is pretty much the same, but you've got an ebb that goes to about 5-6 knots. You'll see the whirlpools. And if you see a flood starting, this is the end of a flood, you might be able to see some of those big waves. However, who wants to hang around for 5 or 6 hours? You want to get in there sometime around here. You can see the ebb and then the flood. So everybody bored with tides now, I expect. A brief appearance of Mercury. It looks much better in the southern hemisphere because the ecliptic is pointed down. It points up to the right, but not steeply. From the southern hemisphere, it's a much steeper into the sky curve, and you'll see Mercury come higher. And what you're seeing here, that's Mercury at its greatest western elongation, 24 degrees. So you're looking this way at Mercury. There's Mercury, Sun's here, Venus is here. Mercury has done this. It's come in front of the Sun relative to us, and now it's heading around behind. But this is as far out as it gets. Tilt that, and this is what you're seeing. So this is the 12th in the morning. And you can see stars here. This is Antares in Scorpio, the scorpion, which you can normally see in the summer in the southwest. Well, of course, this is the southeast. And those are the 3 stars there. They're his claws or something. Acrab, I think, something. And this one I always remember, Fang. It's a Chinese name. So there's Antares. And down here is the stinger, Shaula, somewhere. Anyway, you've got Venus and Mercury. And if you look 6 days later, they look the same, but the stars have moved because we're all going around the sun like this, and the stars appear to be moving to the right. And yeah, this is going to be about 2 degrees above the horizon, maybe 3. It's tough to see, but it is what it is, as they say. Jupiter's moons. I think these are really cool because you can see them with binoculars, not to this extent. These are all stellarium screenshots, of course, but they're remarkably accurate. And you think, okay, so this is 8:55 tonight. Yeah, in 12 minutes from now. Seriously, that's why I picked this one. And up here, you've got Callisto, Ganymede, Europa, and there is Io or Io. I've heard it pronounced both ways. I don't know. And where is it? Well, there it is. And this is the way Stellarium shows it to you, because you see it as a star if it's separate from Jupiter, because it shines. But it's right there. They're showing it in front of Jupiter, and there's its shadow, because the sun is to the right, and its shadow falls. There's the great red spot, by the way, and you notice the shadow is elliptical because it's landing at an angle on Jupiter. Now, I have never seen with any of my telescopes satellites pass in front of Jupiter that I could recognize or seen the shadows. But I do believe they happen because people have told me they do. So, but you can see this sort of thing. Here we are. This is the 21st in the evening. There they are, Io, Europa, Ganymede, and Callisto in the order out from the planet. And here they are spread out on the other side, Io, Europa, Ganymede, all Callisto's way over here. And personally, I find it really interesting when Neowise was in the sky, 2021, I think. I took a pair of the club's stabilized binoculars down to the pier, and I showed hundreds of people who came down to see the comet. I showed them, what's that? That was Jupiter. And when they learned what that button was for, they could see the moons of Jupiter through a pair of 7 by 30 or 8 by 30 binoculars. And that was impressive because otherwise, it's almost impossible. And this is what happens when they're all lined up very close to Jupiter. And this is that tough conjunction I was talking about, the 27th, 725. This is 3 degrees above the horizon. And if it's clear, you've got a toss up between increasing twilight and, okay, now they're high enough to see, but the sky's too bright and I can't see them. So it's tough. Venus, of course, is up there like a street light. Anyway, so there's that. And this is today's solar system chart. This again is from Heavens Above. If you don't go to it, learn. It's lovely. There's the Earth, here's the Sun, Mercury, Venus, and Mars. And you can, whoops, stop that. You can see we're almost at right angles. So this is why Mercury's as far out as it gets. Venus is just past as far as it gets. And Mars is on the other side of the solar system. And you can see how elliptical Mercury's orbit is and Mars. Earth and Venus are pretty much circular. Jupiter, Saturn, Uranus, Neptune, and the latest non-planet, poor old Pluto, which is quite elliptical. But it's got a lot of friends way out here. Some of them are bigger than it is. So it was only 1930 that Clyde Tombaugh discovered Pluto. 21 years later, we were born and learned that there were 9 planets and so on and so on. And look at all we know now. I'd like to think I know more than I did back then, but the body of knowledge, yes, is growing. Hopefully I'm retaining some of it. Anyway, there we have it. That's what you'll be able to see, assuming there's no clouds.